Thank you, everybody. I'm really excited for this opportunity to talk to you all about developing telecom and just tech applications in general. Hopefully this talk can enlighten you a little bit, expand your mindset, and how you guys view building applications. Right now, we're in an incredible wave of technological advancements, from the way that we are gathering information, from literal information, whether it be YouTube videos, reading things online, accessing different programs, being able to obtain data, as well as our mediums for expressing that, whether it be through AI, VR, maybe we have video conferencing. 20 years ago would be something that's completely radical, but now with the current implementations, we're able to scale these things and really roll out on standing on the shoulders of giants with some of the implementations and the methods that we're able to go over. So today we'll be talking a little bit about myself, being Jon Gray. I'm a solutions architect here at SignalWire, and most of what I do is transferring what business problems people have and conforming those into technical solutions. So what we can actually do on the technical end to activate and perform business problems, and whether it be a problem that's been existing for hundreds of years that we're now able to solve, or with the realization of new business possibilities and the different struggles that come along with that. So first, we'll be going over some of the cloud computing landscape, so where we're at, kind of the history of why we got to where we are, and how we can further implement those. When we talk a little bit more about the architecture of some of these applications, we'll split those off into two sections, one being the business factors, and the second being the technical factors of what is needed in order for an application to run. Next, we'll talk a little bit about SignalWire Cloud as a solution, kind of touching a little bit about free switch stuff, SignalWire Cloud, the relationship between those, and even touching a little bit about some use cases so we can do some storytelling, and then how we can leverage all of that into what you can build today. So computing landscape, we can talk early thousands of years ago, just simple computational in abacus, or different mathematical computations that are being done, and really just creating different implementation methods for doing computation. So from thousands of years ago to then, we talk about World War II, where we start having actual encoding processes being done, automating a lot of these different processes, and being able to actually develop computers and make them accessible. So around 1950s or so, we have the UNIVAC, which was the first globally distributed kind of commercialized computer that people were then able to have access. But in talking about cloud computing and some of the things that we're able to do, talk first about 1960 with time sharing. So multiple users are then able to access a similar terminal. So what's really revolutionary about this is, before we had people running computers that were static, one machine doing one process, and it can just run that through. Now we have one machine, now we have multiple machines, but we have one process that we're able to implement and kind of tinker with. Skyrocketing productivity, increasing collaborative nature of just communicating between domains and communicating between different machines. And then we can talk about just 1 year prior. Now, although this isn't a grand and extreme technological advancement, John McCarthy from MIT, in a lecture in a computer science class, had a prediction that computing resources would be treated as a commodity, kind of similar to what we have for oil or gas or milk or eggs. Right now, we can put a price on a resource. But rather than putting the price on the physical components that go into a computer, we're now viewing these digital resources as something that's a commodity. So putting a price on digital resources and using digital commodities as a form of exchange. Whereas before, we had the price of a box, or I guess back then the price of a whole room, in order to get some of these vacuum computers to run. And then fast forward to 1990. So virtual machines become popular. We have one machine, but it can run multiple processes. So whether we want to offload this to diversify ourselves, or just using this principle in order to expand the possibilities of what we can do with just one single computer, we're now able to incredibly diversify our possibilities with that. Fast forward a little bit farther, we have in 1999 Salesforce dropped, and although big fan of Salesforce, also not a big fan of Salesforce, but one thing that they did revolutionize the game for us is introducing software as a service. So software now being viewed as a commodity just the same as a computer would be, a server would be, or really any other piece of hardware. But we're now able to sell software and put a price and on how effective it is, as well as all the resources that go into maintaining that. Introducing hyperscalers, so in 2006 to 2010-ish, we have AWS and a lot of these other big companies that are now creating warehouses, completely saturating the market of what computing resources were capable of doing. Now we have thousands and millions of computers running, whereas before everyone was kind of localized, privatized, and maybe you were lucky to get your hands on some of their servers. Advancing and building back upon that, we have Docker and Kubernetes in like 2013, 2014, introducing dependencies, containerizing a lot of the previous offerings that AWS had by making them more dynamic, more dependable, more static, more just stationary, that we can actually run these kinds of things. And then 2018 with edge computing, so putting things a lot closer, increasing global connectivity. This trend completely revolutionized what we're able to do with a lot of real-time communication, as well as other industries who aren't so based in telecom. Then we can talk about today. So today, we're implementing all of these practices. Today, it's a lot of fine-tuning. It's a lot of being able to use what other principles have been already established and then building back on top of those. And we'll be able to see, as we talk a little bit more about the use cases, how we're able to do that in kind of real time. But something that I wanted to kind of go over with this whole timeline is just some of the trends of where these processes are physically located and physically ran. So when we introduced the first computer, we have people running stuff on their own computer. We had the government having encoding processes, or they had little census readers, where you can read a punch card. But businesses are grabbing and using their own resources in order to make these things possible. Fast forward to time sharing, now we're implementing things on other people's computers. So now what was previously storing stuff on your computer, we can now do on other people's computers. Fast forward a little bit back to virtual machines. Now we have one physical machine with multiple stuff, so then we're back onto our own. Then we go to AWS, and then we are now offloading processes to other people's computers. So the process coming back and forth of running things on our own systems versus offloading them versus being accessible to run on our own to then offloading them, we get this back and forth of where physically these processes are being stored and where they're being ran. And on top of that, another traction another trend that I want to discuss is really the business and technological advancements and how they play a part in exchanging with each other. So business needs promotes technological advancements and some of the innovation that's required for those, as well as technological advancements help us solve business problems that we didn't even know that we were capable of solving. So a lot of back and forth between those two, the relationship between that, although it may seem simple when you're able to look at it on kind of a larger scale, take a step back and further look at it. It's really interesting to see the symbiotic relationship between those two. So where is the cloud? And what is the cloud really? Rather than dealing with the technical implementations and nitty-gritty of all that, we'll just say that cloud is basically a room with a bunch of servers. Maybe there's some guys that are hanging around and making sure that no one's cutting cords or unplugging wires or anything like that. And this is what the cloud looks like from the cloud. So really hot boxes, servers use a lot of resources, usually by bodies of water just for cooling sake and environmental friendliness for when they go about it. And then this is a cloud in the cloud over all of the clouds. So lots of clouds going on over here, but ultimately it's just a bunch of computers that we're able to share resources with and being done on a corporate level. Now, on-prem servers, right here we have Pied Piper and their on-prem servers. A little dark, but maybe you could see really just a closet. It's got a bunch of servers, computers running in it. It's probably got some boxes and other stuff. You likely have a guy similar to Guilfoyle, or maybe he looks like Michael Jarris or something like that. But they kind of all look the same and have the same personalities as they're maintaining their own infrastructure. Then on-prem, from the view of the on-prem development, we have some guy who maybe built it, maybe didn't, but things metaphorically and literally can catch on fire quite quickly. So on-premise, physically having your infrastructure on the premise versus having it outsourced into some of the other data centers. In talking about the different factors that we take into consideration for architecture, starting with the business side. As you guys can probably imagine, money is definitely the biggest topic of discussion. How much is it going to cost up front? How much is it going to cost to maintain? How much money do I have right now? And what is actually feasible? All important factors. Pace of development, or time to value, and the fickle nature of tech and kind of where we're at right now. A lot of startups being on different verges, needing things to be done today. We need to start making money. Maybe there's an event that's happening which you need this application done for. Maybe you're back in World War II where you need to get this developed before something crazy or bad happens to your entire country. A lot of pace of development, or when the time for when something needs to be implemented, is very important for when we're taking a look at some of these applications. Service level objectives, kind of just how well the thing does the thing. So how much of your business needs are being actually solved by this technical implementation. We can quantify that, we can qualify it, whichever methods that you are able to look at it and really justify whether the thing is doing the thing that you want it to do. Is it worth even building? Incident recovery time, so a lot of businesses being very fickle in the sense of what needs to happen when something goes down, some more important than others. Emergency services obviously need to have a lot more resources dedicated towards incident recovery time than, let's say, your marketing company that's sending a little blast or something like that. Compliance, everyone's least favorite topic, but dealing with the regulations, what needs to be done, are these technical implementations or are these business processes that need to be put into place? And the fun side, the technical factors. Biggest kind of overarching topic would just be computing resources. So both on a physical level of where is this being hosted, do we have enough CPU processing power to actually do the thing that we need to? Is the software that we're implementing actually able to be implemented? Are they able to connect with each other? How integratable is one thing over the next? All of these kind of fall into the topic of just computing resources. So providing yourself and setting yourself up for success with that. Storage requirements, so what data are we taking in, how much, how long are we storing it for, and where is it being accessed from? How quickly does it need to be accessed? All of that fun jazz. Network and security capabilities, really prominent in a lot of hybrid solutions or communication between two different application scenarios. If we want to whitelist domains, if we want to deal with firewalls, if we need to deal with any virtual networks of any sort. And then the ilities, or as I call the non-functional requirements. So some things that may be quantifiable, but ultimately just rely on how well we're able to use this in order to scale, in order to be available, in order to be reliable, in order to actually deliver the thing that we want the thing to do. So if all of these factors are taken into consideration equally, we have a nice pie chart. Obviously, if all things were infinite and we had infinite resources, we would have immense capabilities of having the pace of development skyrocket, or having service level objectives be completely nailed. But in reality, we have a finite amount of resources. We only have one pie chart, so we can kind of shift and change the way that we view these applications based on some of the business factors for architecture. And these then lead into the technical requirements. So as we go through some of the use cases, you'll see how compliance or regulations might change how well we look into network security, or how the service level objectives is an immensely CPU intensive process, and we need to delegate more time towards the computing resources or anything of the likes. So we talk a lot about cloud benefits and some of the great things that are possible for you, but it would be a knock to not talk about some of the benefits for being on-prem. The first being complete configuration control, so being able to decide what you want on your infrastructure. You can add what you want, take away what you need. You can manually adjust anything that you want to. You have full control, and you can do whatever it is that you want. Next, some uptime confidence. So having an on-prem system, you can physically see that something is plugged in. You can know when a fire or natural disaster is coming. When things are happening in US East, we can't really have any control, and we don't really know what anything is happening over there. So having uptime confidence, knowing that your thing is working, and being able to actually physically see that occurring. Next is one that resonates probably with a lot of the free switch companies in the room right now: lower marginal cost at scale. So running open source may be expensive up at front, but luckily over time you really aren't paying as much as you would if you're paying as you go for a lot of these things. So when you're at scale, when you're cranking out calls like none other, it really pays, and you'll notice some benefits that with some cost. And the last one is a benefit, but can also be a drawback, and that's security being based on owner experience. So your Guilfoyle may be the best Guilfoyle in the entire country. Maybe you do have a really good in-house development team and network administration, so you know that your security is being handled the correct way, and your owner experience basically caters the way for how good your security would be. For some drawbacks, just general hardware management. Servers are hot, servers are big, clunky, they take up space. You have to physically manage what it is that you have. Screws, bolts, things that we don't really deal with a lot in the software industry. Upfront costs, so buying servers is really not cheap, but once you buy them, you kind of have them forever. So upfront, going to cost you quite a bit in order to get everything up and going. In-house administration, so what I mentioned before may be a benefit, but oftentimes, most of the time that we see actually ends up being a drawback to what is possible. And lastly, time to add resources. So something that we don't think about so much are just how many pieces go into the puzzle for on-prem solutions. Things like how to actually receive a server, or ordering it and delivery time. When COVID hit, there was an immense shortage of people being able to buy servers, not because there weren't any servers, but because pieces of hardware to actually put the racks into place were being stopped with shipments from China, and not being able to have just one little piece that would keep the servers on the racks caused people to have to literally put servers on top of bricks, on top of 2x4s, finding little spaces in between here. I was talking to Evan a little bit earlier, and he was mentioning how when he had a large data center, he wasn't able to have the closing port for some SD cards. What he ended up doing was literally duct taping these disks on top of inside of these servers and being able to make that work. He said it worked, but again, having time that you may not have is definitely something to take into consideration, because there's a lot more factors that go into play when you're dealing with hardware and purchasing from multiple vendors. Some benefits of cloud by nature: just global connectivity, being able to access anything from anywhere in the shortest amount of time. Kind of by nature what cloud does and why it's so popular and efficient. Affordable upfront costs, so being able to start your application without breaking the bank automatically. Having a price model that's a little bit more scalable, something that you can predict, and something that over time you can actually manage. So not having to spend all your money at one place, but we can say when I get all of this traffic, or when I get this customer later, I will have this money. So it's a business model that we find to be a lot more effective. Businesses are able to survive a lot longer, and they're able to meet any of those cost needs that they have. Next, offloading CPU-intensive processes. So rather than running things on your own computer, rather than using your own resources, send it up to the cloud, have everyone else deal with it for you. It's a lot easier to send an API request than to install all the dependencies and libraries that go across that. So being able to offload a lot of those processes end up making your infrastructure a lot more manageable. And then shorter development period. So time to value was one of the big portions that go into business factors for this, but having a short development period means businesses can last longer. Maybe if they were on the verge, they're now able to make money a lot quicker using APIs and SDKs that are a lot more native to what you're used to, and making them efficient. Rather than reinventing the wheel, you're able to kind of stand on what other people have already developed before and work a little bit further onto that. Then scalability as well, so just the pure nature of being able to scale things, spin up, spin down, all within a matter of seconds, rather than purchasing servers and drawing everything up. Some drawbacks of cloud, outsourced connectivity reliance. So rather than being able to see what you have going on, you're sending it off and not necessarily hoping for the best, but essentially having your connectivity handled by someone that's not in-house. Less configuration control, so you're really only able to do the things that your provider tells you that you're able to do. What offerings do they have, what you can implement, but you are really kind of at the nature of what your provider is able to access for you. Then knowledge and process building for migrating systems, so creating processes around these new APIs or these new processes that you've had in place. What metrics are we able to grab? Learning the jargon and the domain-specific knowledge that you'll really need in order to make this happen. A bucket on AWS is different than a bucket on cloud, is different than a bucket with Microsoft. Or really the names of APIs for anything in a telecom setting. So talking about SignalWire Cloud specifically and how this kind of relates to everything. Distributed design, so having a global network that you can access real-time communication on edge networks that are accessible from anywhere in the world, and having minimal latency when you're connecting to those. Then operational excellence, so how we log, how we read metrics, support systems, crisis mitigation, having a larger team on your back, essentially, for when these issues or anything might occur, whether it's development, whether it's in production. But adding on to your team by not only having your support team, but having a support team of the people who created the product in the first place. Security and compliance, so a lot of authentication, access, just general compliance with what the nature of telecom is specifically, so both requirements on both of those ends. Performance, so scalability, SLAs, SLOs, how we're able to actually do some of these things, and how we're able to interpret that, whether it be from a certain metric. We mentioned how well the thing does the thing for a lot of the SLOs or SLAs, so we can actually quantify how well something's being delivered. And developer-friendly APIs, so reducing development resources, having a relationship with some of these programming languages, and being able to implement the ones that you want to, that actually resonate with what you are able to do. I'm going to blow through some of these, because I know I'm running out of time because I've been rambling too long, but I want to talk about a use case and something that came up to us recently that I'm working with. Say healthcare facility X spending too much money on tedious overhead, on contacting their patients about different test results and appointment reminders and confirmations. So the company has people physically dialing phones, letting them know what they need to do. But rather than doing that, they wanted to look at what other possibilities and solutions are out there. So we look at integrating the healthcare system to automate these outbound dials, let them know of their lab results. In order to have a phone call that lets the user know their lab results, we need to know the lab results and have something that's dynamic. So having a dial plan with access to data in real time, whether it be lab results, whether it be your PIN, whether it be any other information that might need to come through, support case or the likes. Next big port was integrating their calendar platform to notify upcoming appointments and also create them. So how we can take information from a calendar, implement that into a voice call, how we can take information from a voice call, implement that into other APIs and other environments, making things flexible in that nature. They wanted to have something that was easy to use for elderly patients. A lot of what they had was too static. People were not able to answer the prompts. A lot of IVRs require you to say specific things, and if you have maybe an accent or you're mumbling, they get a little bit tricky. So added resilience with the IVR, with AI and using some of those. Lastly, HIPAA compliance with some data privacy practices, and then minimal dev resources, so versatile implementations and different programming languages with that. We can then see how our chart previously was perfectly symmetric. We had everything compliance, opportunity costs with a traditional, just run-of-the-mill company probably be perfectly even. However, with them specifically, because they had so many HIPAA regulations and requirements, we see this portion of the pie chart getting far bigger. We also see a lot of the network and security portion of the technological requirements growing as well. The service level objectives, they needed to have a new implementation that was better than the last one. So that was something that was really important to them, how well this application actually solved the problem that they were going for. And we can see a lot bigger chunk of the pie being used for the non-functional, like the illities, as I mentioned before, for those technical factors. I have some other use cases that I'm unfortunately going to have to skip through because I talk too much. But in leveraging the cloud today, before I get kicked off of here, lifting and shifting, how you're able to do it right now, rather than migrating your entire infrastructure, you can do it piece by piece. Some big, just converting free switch dial plans to hosted XML, use SignalWire Relay, use SWML, but having your resources be able to actually implement some different stuff. Automate your SIP and PSTN infrastructure by migrating through UIs, APIs, but how you're changing the resources that you have available. So migrate the resources and restructure their implementation, how they're being used. Next, for hybrid solutions, if you want to not specifically have your own, but you want to add on and mix to the next, use PSTN transfers. That way you can actually handle some things with not only what you have right now, but you can also add on to phone numbers, have them run their own process, and simply by using transfer or refer, we can add on to what the existing infrastructure was possible with that. Or if you simply want to start a whole new business, whether maybe you're a voice company and you want to now deal with messaging and chat and PubSub or any of the likes, rather than building on what you have currently, try checking out some other things and be accessible to some of those. So last slide, and then I promise, David, I'll be done here. But leveraging the cloud is more accessible than you think. Things are at your fingertips. They're very easy. They're very accessible. You don't have to migrate your entire infrastructure. It's not as grandiose as you might think. There's a lot of things and processes in place in order to make it more simple for you. Rather than doing the whole thing at once, you can kind of piece puzzles together. Next, think like a cloud. So be flexible like a global network. Manage your scalability and prioritize efficiency like a load balancer would. Connect to the tools at your fingertips like an edge network. Diversify your offerings like a virtual machine. And you can enhance your offerings and make them more dependable like a container. Lastly, be curious, just like Ted Lasso. Shout out to not be stuck in your own ways. Think of what other people are doing. Build on top of that. Play with stuff. Submit bug reports, the whole 9 yards. But be flexible. Be ready to adapt to the ever-changing landscape that is this technological industry that we're in, and empower the world. Stand on giants by using what other people have done previously and implement your business the best way that it possibly can. And thank you, everybody.
Thank you, Jon.